Okay. So sorry for about 10 minutes. I could have covered without notes also, but the problem is that then we need to finish the concise stuff within the time, right? So there has to be synchronization with the notes. Anyway, so we were looking at linear second order differential equation with variable coefficients, right? And I gave you that important result. So there are two. So this equation is known as non-homogeneous equation because when Rx is non-zero. So whenever we are solving these equations, I need to solve it in two parts. First, look at the homogeneous equation. That means put Rx is equal to 0 and solve it, right? Okay. Find a general solution of a homogeneous equation. Then somehow, although I will tell you techniques also, somehow find one particular solution of the whole equation. Means a function which satisfies the whole equation. Add these two things and you will get all possible general solutions for the non-homogeneous equation. And I think that's the result that I covered last time. Right, so this was the result. So whenever we want to solve non-homogeneous equation, look at the homogeneous equation, and if Yg is the general solution, why there are two constants C1 and C2? Because it's of order 2. Okay, general solution of the GS means general solution of the homogeneous equation. Okay, 2, and Yp is any particular solution of the whole equation, 1. Add them and you will get the general solution of the equation 1. I have given the proof of it, but that's the thing. Now the question is, how do we find general solution of the homogeneous equation? Okay, that's the thing. So first we focus on that. Now in order to find, so we are now focusing on this homogeneous equation, and I wanted to give you this fact that number of constants in the homogeneous equation solution depends on what is the order. Here there is order is 2, so there are 2 constants, right? So I think let us take a very specific example. So if we look at the equation y double dash plus y is equal to 0, so how do we find y1 and y2? Leave it aside for a minute, but at least you know that y1 is equal to sin x is a solution. You can substitute, and similarly y2 is equal to cos x is a solution, right? Not only that, its linear combination is also a solution, right? Why this linear combination things comes into picture? So now let me give you some idea. If I define a function, before that actually, first of all let us take this R square. If you take a point x comma y, you know that x axis can be written as 1 comma 0 vector, right? You can write like this. Now you see, note that any point xy in R square, xy can be written as linear combination of, say, c1 times 1 comma 0, sorry, not c1, x times 1 comma 0 plus y times 0 comma 1, right? That means we call that R square is spanned by these two vectors 1 0 and 0 1, right? Okay, that means any point in R square is linear combination of these two vectors. So these two vectors, we call this set as basis. What does that mean? Number one, that any point x comma y in R square is a linear combination of elements of B. Okay. Number 2, these two vectors in B are linearly independent. Please note these notations which I am using. LC matlab linear combination. okay, and Li means linearly independent. What do you mean by linearly independent? If I take one vector, it is not a linear combination of the other, means one is not a scalar multiple of the other, they are linearly independent. That means if I take linear combination of two vectors, put it is equal to 0, those scalars will be 0, okay. So linear independent means 1 0 is not equal to lambda times 0 1 for any lambda in R. Do you agree with this? Right, you cannot express one vector in a linear combination of the other vector for any scalar in reals, right? So these two vectors are linearly independent, okay. So this is a very important definition. In general, if we have n vectors, so we say that, so I can actually rewrite it for n case. So vectors, so I would say that vectors are, so I will suppose v1, v2, vn are vectors, they, you know, okay, these are linearly independent vectors, I would say, if whenever we have summation lambda I vi is equal to 0, I is equal to 1 to n, this will imply that all scalars are 0. Means you cannot find a combination of vectors like this, right? If you can find at least one non-zero lambda I, that means vectors are dependent, okay. One such example is, look at this. So for n is equal to 2, if I take 1 0 and if I take 1 1 and if I take 0 1, right, these are the three vectors. Are they linearly independent or dependent? Dependent, right, because 1 1 is linear combination of 1 0 plus 0 1, right. So this is scalar turns out to be 1 times 1 0 plus 1 times 0 1, right. So that means I am able to find a relationship among all the vectors, right. So these are linearly dependent vectors, okay. Okay, linearly dependent vectors, whereas these vectors are linearly independent, right. These two are, so these are known as basis element, okay, of this vector space. Now in a similar manner, I can actually go and I can say that what about R cube? So it's called as a vector space, three-dimensional vector space. So any point x, y, z is linear combination of 1 0 0 plus y times 0 1 0 plus z times 0 0 1, where x, y, so x, y and z belongs to R, right, each separately belongs to R, right. So that means any point in the three-dimensional space is linear combination of these three vectors, right. And these vectors, are these vectors linearly independent? So if I say that B is 1 0 0 0 1 0 0 0 1, is this a basis? So there are two conditions for basis. First, they should be linearly is a basis if any point in this whole space is linear combination of the vectors, right. Second, in other words, we say that these two vectors are spanning the whole space. Second, they are linearly independent, right. These two conditions should be satisfied. Now if you look at in case of R cube, so first of all, are these vectors linearly independent? So we call it as unit vectors. So I will denote them E1, E2, E3. We call it unit vectors, right. So can I find lambda 1 E1 plus lambda 2 E2 plus lambda 3 E3? Suppose this is equal to 0. This will certainly imply that lambda 1 is equal to 0, lambda 2 is equal to 0 and lambda 3 is equal to 0, right, because you cannot find the linear combination, you cannot find non-zero lambda such that this linear combination is 0, right. This is possible only if lambda is a 0. So these three vectors are linearly independent, okay. Got the idea of linear independence? Now, so that means this set is acting as a basis. And second thing is that, of course, this is our second condition, which says that, so second condition is R cube is spanned by E1, E2 and E3. Spanned by, right. spanning the whole set. Got this idea? Right? So this is, I am giving you just example of vector space. Of course you will look at these things in more details, but once you have this understanding, it will be easy for you to understand in terms of differential equation what is happening. Okay, got it? So this is a very easy idea, right? So any vector space means collection of vectors where you can play with the vectors. Means if you take two vectors, add them, you are in the set. Take a vector, scale it by lambda, you are again in the set, right? It preserves linear combination kind of thing, right? That is the main property of the vector space. So basically R3 is a vector space and this is the basis, okay? And similarly R2, R square is the plane is a vector space with two vectors 1 0 and 0 1. These are linearly independent, right? Got it? Any question with this? Clear? Now we go and look at the solution of the differential equation, okay? Homogeneous differential equation. So now I define what is, linear independence in terms of vectors. But what happens, let us take an example now. Y double dash plus y is equal to 0, right? So you know that one solution is cos x, another solution is sin x, right? Yeah, sin x cos x kahin pe rakho, right? How will you check whether these functions are linearly independent? I want to check this condition whether these functions are linearly independent. So basically solution space of the homogeneous differential equation behaves like this vector space. Means any solution is a linear combination of two independent solutions, right? That idea is I am bringing it here. So now if you see that, so the general solution is what? C1 times sin x plus C2 times cos x, right? For two constants C1 and C2. So linear combination, right? So sin x and cos x are the linearly independent functions. So there should be condition. How do we check? Obviously one way is that, can you find a dependency between the functions, right? So essentially there is a condition given by Wronskian. Wronskian was a mathematician. So let us do this. He said that compute these two things, y1, y2, y1 prime, y2 prime. y1 is a function, y2 is a function, y1 prime is differentiation with respect to x, y2 prime differentiation with respect. So this is determinant. So this is y1, y2 prime minus y1 prime, y2. Just compute this quantity. And actually he showed that if this Wronskian is non-zero in an interval at any point, then the functions are linearly independent. Okay, so just compute the Wronskian here. What will be the Wronskian for? Anyone can tell me what is the value? y1, y2 you know, y1 prime you know, y2 prime you know. 1, right? So non-zero. So these two functions are linearly independent, right? And that's the reason any solution, general solution of the homogeneous differential equation is linear combination of these two functions, right? So that's the reason this is 1 which is non-zero, right? So these are linearly independent functions. Got it? So that means general solution is y1 is equal to c1 times cos x plus c2 times sin x for two arbitrary constants c1 and c2. This is the general solution of the homogeneous differential equation. Right? Okay. So now I will look into a bit more details about the Wronskian. I gave you an example and the motivation about it. Right. Now let us look at the main result given by Wronskian. Okay. This is lemma 1. So lemma 1 says that if y1 of x and y2 of x are two solutions on a closed interval a comma b, two solutions of that homogeneous differential equation I am talking about, right? That second equation, I am saying this equation, right? This equation. So suppose y1x and y2x are solutions of this differential equation, right? Then it says that if we compute Wronskian, then there Wronskian was a name of the mathematician. W, which is W of y1 y2, is either identically 0 or never 0 on a comma b. Essentially it will say that either they are independent or dependent, right? The Wronskian is either identically 0 or never 0 on the closed interval. So let us do this. Since W is y1 y2 prime minus y2 y1 prime, or in other words y1 y2 y1 prime y2 prime, right? That's a determinant. By the way, do you know how do you differentiate a determinant? मालूम है differentiation? Differentiation of the whole thing with respect to x is whole thing first row plus whole thing differentiation of the second row, right? You can compute that, right? That's a easy thing. Anyway, so I can write it down. W prime will be what? y1 y2 double prime plus y1 prime y2 prime minus y2 y1 double prime minus y2 prime y1 prime. So this means क्या क्या कट गया, ये और you are left with y1 y2 double prime minus y2 y1 double prime. This is a differentiation of the Wronskian, right? Okay. Now both y1 and y2 are solutions of the homogeneous equation, so they will satisfy the differential equation. I can write those values. So this is your, I would say that, call it equation 1 or whatever. Now y1 and y2 are solutions of homogeneous differential equation, right? So we have y1 double prime plus p times y1 prime plus q times y1 is equal to 0, because y1 is the solution of the homogeneous equation, and y2 double prime plus p times y2 prime plus q y2 is equal to 0, right? Now multiply first equation by y2 and second equation by y1 and subtract. Okay, so what you are going to get? y1 y2 double prime minus y2 y1 double prime, sorry, y1 y2 double prime minus y2 y1 double prime plus p times y1 y2 prime minus y2 y1 prime is equal to 0. पहली इक्वेशन को हमने y2 से गुणा किया, दूसरी इक्वेशन को y1 से गुणा किया और सब्ट्रैक्ट कर दिया, रीअरेंज कर लिया टर्म्स, वी विल गेट दिस, राइट? नाउ व्हाट इज द फर्स्ट थिंग? dw over dx Wronskian का डिफरेंशिएशन है, एंड सेकंड थिंग इज Wronskian itself. So this implies that we are getting dw over dx plus p times w is equal to 0. अभी क्या हो गया, ये फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन. एक चीज जरूर ये है कि w अभी Wronskian है, बट दैट्स ओके, सम फंक्शन ऑफ x आई एम अज्यूमिंग, राइट? So first order differential equation homogeneous and you know how to solve it. First order का तो अभी हमने देखा था ना, वो integration e raised to power p dx करके, right? So I can use that formula here. So general solution of this equation will be W is equal to constant times e raised to power minus integration p dx, right? And now this is not equal to 0. This implies that W is 0 if C is 0 and W is not equal to 0 if C is not equal to 0, right? So this solution, so Wronskian actually has this kind of expression, right? And our theorem was, lemma was, Wronskian is either 0 or never 0, and so this depends on this constant C, right? If C is 0, Wronskian is 0. If C is not equal to 0, Wronskian is non-zero. Got it? So our result is done. So now next lemma 2. By the way, whatever I am doing for order 2 can be done for order n, but वो तो आप आसानी से कर लोगे चाय के कप के साथ, right? So if y1x and y2x are two solutions of y double prime plus px times y prime plus qx times y is equal to 0 on a closed interval a comma b, then y1 and y2 are linearly dependent as a function, right, on closed interval a comma b, if and only if their Wronskian y1 y2, which is y1 y2 prime minus y2 y1 prime, is 0. So this result says that, so first result says that Wronskian of two functions is either 0 or either non-zero, right? So two cases possible. Now we are having another stronger claim that if y1 and y2 are basically, if Wronskian is 0, then y1 and y2 are dependent. Okay, इसका मतलब है इंडिपेंडेंट कब होगा जब नॉन जीरो होगा Wronskian, right? You just saw the case, sin x cos x are non-zero है, right? So how will you prove this, by the way? A cup of tea. So assume, I am giving you a hint, assume y2 is c times y1. ये assume कर लो, डिपेंडेंट है तो मतलब y2 is a combination of y1, right? Substitute कर दो, you will see the value is 0, right? ठीक है, fairly straightforward thing. तो lemma 2 भी हो गया. And now we have the final result. Final theorem. अगर y1x और y2x linearly independent solution है of the homogeneous equation y double dash plus px times y prime plus qx times y is equal to 0 on closed interval a comma b, then general solution is c1 times y1x plus c2 times y2x. That means for two constants c1 and c2. ये तो अभी मैंने तुमको बताया ही है. अगर दो linearly independent solution आ गए तो I can get any solution, and this is kind of property of that vector space, right? If these are linearly independent, they are going to span the whole space. दो ही हैं तो पूरा space generate कर देंगे, right? वैसे यहाँ पे बहुत सारे ब्यूटीफुल चाय के क्वेश्चन बनते हैं, सॉर्ट ऑफ. हम तीन फंक्शन ले लें मान लो. कैन आई से दैट कि तीन इंडिपेंडेंट फंक्शन इस इक्वेशन को मतलब इंडिपेंडेंट होंगे और इसके सॉल्यूशन भी होंगे? कैन आई से दैट? कैन आई से दैट 3 linearly independent solutions I will be able to find for this second order differential equation? हाँ, नो राइट, बिकॉज ऑर्डर 2 है तो 2 से ज्यादा हो ही नहीं सकते लीनियर इंडिपेंडेंट सोल्यूशन, राइट. दैट इज काइंड ऑफ जस्ट लाइक दैट आर स्क्वायर और आर क्यूब में डायमेंशन था वो, राइट. कितने बेसिस में एलिमेंट होंगे, राइट. अगर आर स्क्वायर में 2 थे तो 1001 था, आर क्यूब में 3 थे तो 1000100001 था, राइट. सो हियर वी हैव सेकंड ऑर्डर डिफरेंशियल इक्वेशन. तो 2 लीनियर इंडिपेंडेंट सॉल्यूशन काफी है जनरेट करने के लिए फुल स्पेस को, राइट. अब 2 ये हो सकते हैं या कोई और हो सकता है. दैट्स अ डिफरेंट स्टोरी ऑल टुगेदर, राइट. इट्स अ वेरी वेरी रिमार्केबल थिंग एक्चुअली, यू नो. Okay, so now time is there when we can do some example. ये एग्जाम्पल बहुत ट्रिवियल है एक्चुअली, कुछ इसमें मजा नहीं है, राइट. ठीक है, करना है तो कर देते हैं. वैसे पहली बात तो शो करो कि y1 इज इक्वल टू c1 sin x प्लस c2 cos x is a general solution of 2. कैसे करोगे? हमें अभी तो दिखाया है मैंने, sin x cos x निकाला है, रॉन्स के नॉन जीरो है, दोनों लीनियर इंडिपेंडेंट है, राइट. तो C1 कॉम्बिनेशन विल बी जनरल सॉल्यूशन. एनीवे सॉल्यूशन तो होगा ही, बिकॉज यू कैन सब्स्टिट्यूट एंड शो दैट दिस इज आल्सो ए सॉल्यूशन. y1 इज इक्वल टू sin x डालोगे तो भी सॉल्यूशन है, y2 इज इक्वल टू cos x डालोगे तो भी सॉल्यूशन है, लीनियर कॉम्बिनेशन करोगे वो भी सॉल्यूशन है. और लीनियर कॉम्बिनेशन जनरल सॉल्यूशन होगा इफ sin x एंड cos x आर लीनियरली इंडिपेंडेंट, व्हिच इज ट्रू बिकॉज नॉन स्केन इज नॉन जीरो, राइट. हो गया ना. एंड सपोज कंडीशन इज गिवन देयर दैट y0 is equal to 2 and y prime 0 is equal to 3. This is initial value problem. Find particular solution. So we know that this is a solution, right. Now you put these conditions, right, just substitute and solve it. You will get c1 is equal to 3 and c2 is equal to 2. So y is equal to 3 sin x (2 cos x) is a particular solution, right. y ये solution है, x equal to 0 कर दिया, एक इक्वेशन मिलेगी, डिफरेंशिएट करके x equal to 0 कर दिया, दूसरी इक्वेशन मिलेगी, सॉल्व कर लिया, c1 c2 की वैल्यू निकाल ली. ये तो कोई हाई स्कूल का बच्चा भी कर लेगा, इसलिए मैं करता नहीं हूँ ये सब, राइट. समथिंग वेरी सिंपल, राइट. So you have the general solution, the particular solution. Fine, got it. So ये बहुत important है actually. Later on you will see that when we look at second order differential equation with homogeneous coefficients, then we will transform with constant coefficients, basically homogeneous differential equation, second order linear differential equation with constant coefficient which is homogeneous. So this equation will be converted into a algebraic equation, quadratic equation, जिसको हम सीधा 4 फार्मूला से सॉल्व कर सकते हैं, and then we can find values and so on. So we can find 2 linear independent solutions and then we can find the general solution. Okay, so now we are now look at this equation again. Our equation is this. So we know that if we are able to find y1 and y2 as 2 linearly independent solution, general solution is c1 times y1 plus c2 times y2, right. But question is how to find y1 and y2 at the first place. y1 y2 को कैसे फाइंड आउट करें, राइट. अगर इंडिपेंडेंट दो मिल गए तो जनरल सॉल्यूशन आई एम एबल टू राइट, राइट. हाउ डू यू फाइंड y1 y2? तो यहां पे अभी हम थोड़ा सा ट्रिक करेंगे. सो हम अभी थोड़ा सा एज्यूम्पशन डालते हैं. चलो 2 की जगह हम मान लेते हैं एक सॉल्यूशन किसी ने बना दे दिया हमको, 1 सॉल्यूशन. एक पालों में तो दूसरा निकाल लेंगे हम, ठीक है. यहां तक चलते हैं. एक दे दो हमको, दूसरा दे देंगे. कैसे करेंगे? सी जब भी किसी है ना, जेबीएस हार्डन ने क्या बोला है, वेन एवर यू आर इन ट्रबल, कुछ अगर तुम डिस्कस कर रहे हो, इक्वेशन में फंस गए हो, तो मतलब ये मतलब किसी बिजनेस सिचुएशन में ही फंसे हो, कुछ चीज़ मालूम नहीं है, सपोज दैट इज एक्स, राइट, कुछ अननोन मान लो एक्स, डाल दो इक्वेशन में, एक्स को सॉल्व कर लो, दैट इज द टेक्निक, हर जगह काम में आती है, ठीक है। कोई भी अननोन सिचुएशन में उसको कुछ चर मान लो, हिंदी में बोलते हैं चर, राइट, वेरिएबल एक्स, सपोज आई विल यूज दैट टेक्निक हियर। सपोज y1 is a नॉन जीरो सोल्यूशन। बाय द वे ऑफ कोर्स जीरो सोल्यूशन तो हमेशा ही होगा, y इज इक्वल टू जीरो स्पेसिफाई करेगा, राइट। आई एम लुकिंग फॉर नॉन जीरो सोल्यूशन, कॉल इट इक्वेशन 1, ओके। नाउ assume y2 is एनी गेस पूरी क्लास में कि y2 को क्या ले, हम y1 मालूम है हमको, हाँ क्या क्या, सॉरी m by 1, m by 1, m क्या है और 1 क्या है, अच्छा m टाइम्स y1, ओके। सोचने वाली बात है कि हम ऐसे क्यों लेते हैं, बट आई थिंक सपोज इट इज v टाइम्स y1, m की जगह मैंने y बोल दिया, ठीक है, v बोल दिया, ठीक है, ओके। ये y का उत्तर सोचना पड़ेगा तुमको, क्योंकि यहीं पे पूरी कहानी है, वाई वी शुड थिंक लाइक दिस, बहुत इंपॉर्टेंट चीज है एक्चुअली। मैं चाहता हूं थोड़ा इसके ऊपर सोचो तुम, राइट। एक मालूम है तो दूसरा सोल्यूशन इज सम v इज सम फंक्शन ऑफ x एक्चुअली, so v is some function of x actually, okay. So basically v is, I don't know the value of v for some unknown v, okay. अभी y1 मालूम है, y2 मालूम है, डाल देते हैं इक्वेशन में, सॉल्व कर लेते हैं vx के लिए, राइट। So now y2 प्राइम क्या होगा, v1 y1 प्राइम प्लस v प्राइम y1, एंड y2 डबल प्राइम क्या होगा, v y1 डबल प्राइम प्लस 2v प्राइम y1 प्राइम प्लस v डबल प्राइम y1, राइट। सो दैट मीन्स हमने y2 लिया, y2 शुड सेटिस्फाई द इक्वेशन, हमने खाली डिफरेंशिएट किया था, हमको इक्वेशन में डालेंगे तो y2 प्राइम चाहिए, y2 डबल प्राइम चाहिए, हमने वो कंप्यूट कर लिया, v इज अननोन फंक्शन, आई डोंट नो, सम फंक्शन ऑफ x, एंड नाउ आई एम गोइंग टू सब्स्टिट्यूट दीज थिंग्स देयर, सो वी आर गोइंग टू गेट v टाइम्स y1 डबल प्राइम प्लस p टाइम्स y1 प्राइम प्लस q टाइम्स y1 प्लस v डबल प्राइम y1 प्लस v प्राइम 2y1 प्राइम प्लस py1 इज इक्वल टू 0। सब इक्वेशन में सब्स्टिट्यूट कर दिया, रीअरेंज कर लिया टर्म्स को, वी आर गेटिंग दिस। नाउ सिंस y1 इज अ सॉल्यूशन, this is 0 because this is how the equation is, right. y1 double, since y1 is a solution of y double prime plus p times y prime plus q times y, so y1 double prime plus px times y prime, px times y1 prime plus qx times y1 is equal to 0, right. So this quantity is 0. So we are left with v double prime y1 plus v prime 2y1 prime plus p times y1 is equal to 0. सिंप्लीफाई करेंगे, ये काम तो आसान है, हाई स्कूल का है, राइट। सो v प्राइम इज इक्वल टू, इंटीग्रेट कर दिया 1 ओवर y1 स्क्वायर ई रेस टू माइनस इंटीग्रेशन पी डी एक्स, पूरा इंटीग्रेट कर दिया, सो वी ऑफ एक्स इज इक्वल टू इंटीग्रेशन 1/y1, अरे यार खराब हो गया, 1 दूसरी जगह ही लिख लेता हूँ, राइट। सो v इज इक्वल टू इंटीग्रेशन 1/y1 स्क्वायर ई रेस पावर इंटीग्रेशन माइनस पी डी एक्स, सो y1 तो सोल्यूशन मालूम ही था और y2 इज v टाइम्स y1 इज ए सोल्यूशन, राइट। फाइन, हमने सॉल्व कर लिया, v की वैल्यू निकाल ली, तो मतलब v टाइम्स y1 इज y2, डन। यहां एज्यूम्पशन है कि y1 इज नोन, इफ y1 इज नोन देन y2 इज नोन। एक चीज वेरीफाई करने को रहेगी कि ये y1 y2 लीनियरली इंडिपेंडेंट है, राइट। So that verify over a cup of tea that y1 and y2 are linearly independent, मतलब इनका रॉन्स्कियन नॉन जीरो है, ये आपको दिखाना होगा। थोड़ा सा सिचुएशन थोड़ा अजीब सी है, बट करोगे तो देखो क्या होता है, राइट। यू हैव टू शो दैट रॉन्स्कियन इज नॉन जीरो, मीन दीज आर लीनियरली इंडिपेंडेंट। y1 y2 इंडिपेंडेंट मिल गए तो जनरल सॉल्यूशन मिल गया, c1 टाइम्स y1 प्लस c2 टाइम्स y2, राइट। एक एग्जांपल कर देता हूं मैं इसका, एक्स स्क्वायर वाई डबल प्राइम प्लस एक्स वाई प्राइम माइनस वाई इज इक्वल टू 0, राइट। सो ये इक्वेशन हो जाएगी y डबल प्राइम प्लस 1/x टाइम्स y प्राइम माइनस 1/x स्क्वायर टाइम्स y इज इक्वल टू 0। सो px क्या हो गया 1/x, राइट। एंड सपोज योर फ्रेंड हैज टोल्ड और चैट जीपीटी हैज टोल्ड दैट y इज इक्वल टू x इज ए सोल्यूशन। बाय द वे चैट जीपीटी सॉल्व कर सकता है डिफरेंशियल इक्वेशन के, नहीं ट्राई किया है, उल्टा सीधा ही करेगा, राइट। वो तो एडिशन सब्ट्रैक्शन में भी दिक्कत आती है, राइट। So y is equal to x is a solution. So this is suppose y1, so I call it y2. So v1 is this. So v2 is v times y1 is equal to ये सब सिंप्लीफाई करेंगे, सो y2 टर्न्स आउट टू बी x रेज़ टू -2 डिवाइड बाय -2 इज इक्वल टू -12 x। ये सब तो सिंपल कैलकुलेशन है। सिंस y1 एंड y2 आर लीनियरली इंडिपेंडेंट, ये आपको शो करना है। सो जनरल सोल्यूशन इज y इज इक्वल टू c1x प्लस c2x इनवर्स, एंड वी आर डन फॉर टुडे, राइट। अब अगली क्लास में मिलेंगे कल सुबह 8 बजे, व्हेन वी लुक एट लीनियर डिफरेंशियल इक्वेशन विद constant coefficients, okay।